Hello, good morning, or good afternoon, everyone, and welcome to MATHurdays. Math's so fun, we do it on Saturdays. My name is Teresa Wells. I've been doing this whole online thing for a while, over 10 years now. And each Saturday, I present a math routine and a task that is applicable in the K-12 classrooms across multiple grade levels. And I'm excited to be here today with you. In the chat box, I'm going to post the link to today's slides. You do want to make sure you click in it because even though I'm projecting it on the screen here, it's through the slides that you're going to be able to interact. You'll notice on slide 2, I have a link to MATHurdays. There's many recordings there, contact information, a link to my book, Teaching Math at a Distance. And then on slide 3, I've got two great links for you to bookmark. If you're looking for more templates, and I have about 100 more that I'm going to be uploading in the next week, there's many here already for you. And if you scroll down to the bottom, there are even very mathy styled ones. The second link is to the other MATHurdays sessions where I have close to 40 other rich tasks and blank templates so you can implement it immediately. We're going to get started with a little community building. And if you would come down to slide either 3 or 4, you take your pick. You can go ahead and insert a text box and just tell us what's happening in your life. But if you don't feel that a text box really represents you, feel free to put in images, GIFs, emojis, bitmojis, and more. And Raha, I love this little gift that you have. Tell us a little bit about how you're feeling about spring vibes.
Hi, Teresa. I went outside today to pay my rent, and it was nice and warm, but then I got hit with, I don't know what type of pollen, and I was sneezing a lot, so I was like, oh, it's pollen season in Northern Virginia.
It sure is. It hit me hard, but I can't stay inside when it's so beautiful. I'll share my success. I'm really excited about a fraction unit right now. I'm working with teachers who are needing fractions. So on the bottom right of slide 4, these directions come out of Marilyn Burns' series, Do the Math, and the game is called Cover Up. So I've created an interactive version of this where kids can play online and play together. And so the link is there, but you can also visit my website. I'll have it up hopefully by the end of today. Martha, are you still on? Tell us about the babies going to school.
Well, they're fifth grade babies. We went for 4 weeks. As you know, I live down here by the mountains in Henry County, Virginia, and they tried for 4 weeks back in the fall and then went back to virtual. So we're going back to hybrid starting Wednesday, and I have a student teacher this 9 weeks, and we're ecstatic. We just cannot wait to have our kids back. So we're excited, very excited.
Well, I'm glad you'll be able to, support your students as they come back. That's wonderful. Lara, I'd love to hear more about virtual bedtime story. I mean, if we're thinking about the accessibility that we have with our distance learning, I want to hear more about this. I feel like this is something that could really catch on.
Good morning, Teresa, or good afternoon, actually. So it's Read Across America Week, and our school's PTA organized a nightly bedtime story. So like different teachers from our school sign up to read stories to the kids online as part of our Read Across America celebration. And I love dragons, and Raha got me a little stuffed dragon. So I got a little dragon costume and did a dragon-themed read aloud to my kids and all our kids.
How cool that you have that kind of access to all of those students. That is so wonderful. Gail, tell us a little bit about this escape room. Is this, now you say a virtual escape room, is this, I always have to ask our groups, is it mathy related or is it just pure fun related?
I don't know, and that's why I'm waiting to look forward to it. It is with a group of math people, so I'm thinking it might be math related, but I've never done one, either in person or virtually. So I'm looking forward to just being with friends, but also trying this. I'll have to let you know how it goes.
I'm excited to hear. I have done one escape room before. It was in person, and it was the greatest thing I've ever done with a group of people. Well, folks, there are so many wonderful things on here. I would love to just hang out with you all and chat and build community some more. But I do want to showcase the beauty of this activity. It takes just a couple of minutes, but what it does is it gives every single student in your class the opportunity to be heard. They can be heard through images, GIFs, they can be heard through text, they can be heard through putting little hearts around it. As we saw in Lisa's here, we have some cross communication happening. And I can really, select a couple and start to build this community this way. So thank you for sharing. And let's go ahead and jump right into our math routine. I am so excited to do this math routine. It's called My Favorite Mistake. Some people also call it My Favorite No. There's a variety of other names for it. But here's the protocol that I want to do for online. So there was a favorite movie of mine called Father the Bride, and the father is very stressed out, and he goes to the grocery store to pick up some hot dogs and buns. And in his overstressed out way, he gets mad that hot dogs are sold 10 in a pack and buns are sold 8 in a pack. He gets so mad that he actually rips open the buns and starts separating them and says, I don't need these other ones, and so on. It was a trip. And so this problem was given to students, and their work is there. And on slide 7, and your job in the chat box, we'll do a chat waterfall, and you'll tell us what you notice that is correct in here. We're going to start off by noticing all that is right about this work. And the way a chat waterfall works is you start typing in the chat box, but we all hit enter at the same time. So don't hit enter yet. What is right about this? All right, let that waterfall go. Let's see some ideas in the chat box. And I'll ask a couple of you to turn on your mics and just share with us a little bit more about what you notice. Kathy says they're looking for a common quantity 40. Would you turn on your mic and just unpack that a little bit for us?
So the students seem to, yes, thank you. The students seem to be adding up in both rows for the 8 and for the 10, and they stopped when they reached 40. So it looked like they were looking for a common quantity, which is what you want if you're looking for the same number of buns and the same number of hot dogs.
Awesome. So we're trying to get to this 40. Lovely. Let's see who else, and keep populating this chat box with things that are right. Martha, you mentioned several addition problems are correct. Could you tell us? I would like to highlight the ones that are right. Which ones do you notice in here that are correct?
8 plus 8, 10 plus 10, 20 plus 10, 32 plus 8. And 30 plus 10.
Wow, so we have a lot of just correct mathematics on here. Let's see what else. I'm looking for even more ideas in here. Laura, tell us a little bit about what scaling up means to you.
Hi, so I noticed that the student was trying to scale up, meaning that they're essentially doing multiples, but they're not recording it that way. Like they're moving upwards with both the 8 and the 10. So they're adding another group of 8, they're scaling up. They're adding another group of 10, they're scaling up. So to me, the student is moving upwards by using multiples of the 10 and of the 8.
Ah, yes, I see it now. And Raha, you noticed the word leftovers. Tell us a little bit about that and why that's correct.
So the idea is that if he gets hot dog buns in a pack and hot dogs and buns, there will be no leftovers, because I noticed that there are 10 hot dogs in a pack and 8 hot dogs in a pan. So if he's trying to figure out how many he needs to get to have the common multiple of 40 or common number of 40, so there will be no leftovers in terms of I have to either round up or round down for my packs.
Neat. All right, folks. So now that we have marked all over this, now typically when someone marks on your paper with red marks, it means that something might be wrong. But here we are marking with all the things that are right. The next part is not to identify what is wrong about this, but what else needs to be added or changed. So if you would like to tell us what needs to be added to this or changed, go ahead and type it in the chat box. We're not going to put any markings on the student's work. We're going to put it in the chat box. If you want to add something or change something, go ahead and put it in. Stephanie, you have a question here, and I love questions. I will always bring up questions before statements. You say, what is 16 plus 8, and why might that be important to this problem?
That's where the student could attend to detail.
Nice. So on this 16 plus 8, and a couple of people are writing it equals 24, and then they get to the 32. So the 32 is still a part of this, but we have one little step in between. All right, folks. So the protocol that I used today is on slide 8. If you're wanting to do it the same way as me, you might follow this protocol. And if not, you might think about each step and figure out what you would do differently. Some things that were important to me is that students had the wait time in the beginning to do the chat waterfall, and that I recorded correct things on the students' work. I didn't put any markings for incorrect. And then at the end, you do identify the mistake, but something you would add or change. So that's how I do my favorite mistake online. And now we're going to move right on into our task for today. Before we begin our rich task, I'd love for us to say a problem-solving oath together. And Mandy from Katy, Texas, actually gave me a copy of the problem-solving oath in Spanish. So now I'm like super excited to get everyone I know to do every language out there. And you'll notice that Mandy kept it pretty much the same there. So on slide 10 is the problem-solving oath that I would say. But if there is anyone who would like to say out loud slide 11 while we either read to ourselves 10 or 11, feel free to put your hand up. I love other languages, and I would love to honor it if we have anyone who wants to read that one out loud for us. Lara, go right ahead.
All right. Yo prometo hacer mi mejor esfuerzo. Entenderé los patrones y los números. Usaré manipulativos y dibujos. Cometeré errores. Haré preguntas. Escucharé otras ideas. Mantendré mi compromiso tratando de siempre encontrar otra solución o representación. Yo soluciono problemas. Hago del mundo un lugar mejor.
Thank you so much for sharing that with us. If you would like to pledge this oath today, go ahead and put your name in the chat box. And I'm going to see if we can get more languages out here. So if you do know another one, like Karina, I think it was put in there, let me know. Let's see how many more we can get. And we got some great problem solvers out there. Awesome. Your task today is a little bit different. If you are familiar with our MATHurdays, you'll know that our task is usually very open, and today's starts a little bit more closed. There's some check for understanding that I want to make sure everyone's comfortable with before we dive into the actual task. So on each group slide, I'm on slide 12 if you want to follow along. There is a picture of some gears and 3 questions for you as a group to answer. There are even links if you want to see the picture rotate. You could click on that link and you will actually get to watch it. And you know, there's other links kind of embedded in here if you wanted to watch them. And then there's even a video on how to use this app with that 3rd one. So this is a little kind of prior knowledge check for understanding to do with your group. Once you finish that, your task is on the next slide, and I'll read that out loud to you so you know where you're going. I'm on slide 13, or you can follow along with me. This is a real problem, like a realistic thing. Gears are mechanical, meaning that they're moving parts. If there is even the tiniest defect, teeth can become warped, pitted, or broken. The trick to making gears last the longest is to prevent repeated meetup points. In the practice problems, you created gears that met after a maximum or a minimum rotations. This time, explore a variety of gears and determine the ideal number of teeth for the small and large gear so that they rarely meet up. There's a little table to get you started, but you can continue to do it any way you like. We'll explore this as a group for about 20 minutes, and then we'll come together as a whole group to talk about our findings. So at this point, I'm going to create our breakout rooms. And I'd love for you to turn on your microphones, be ready to say hello to your new teammates, and jump right into the problem. Your breakout rooms are starting now.
The technical tools for.
Okay.
Hi there, Group 3. Just wanted to let you know that you're going to start on slide 16 and then you'll move to slide 17.
Okay, thank you.
Yep.
Okay, so 16.
The back of the truck.
Okay. I'm down on slide 18.
Okay. So I was looking for, there you go. All right.
Where
Okay.
is, she said we can actually watch the gears turning. Where do we find that link?
At the, on number one, there's an link there.
Oh, okay. In the picture? Oh, okay.
Yeah.
Oh, okay. Let's see. I think I was thinking in terms of, oh, wow. Okay.
If you can keep trying, and if not, we're gonna, oh, it goes to settings, but not sure. Okay, yeah. Well, we'll keep an eye on the chat box, and then if you give it a try, or maybe you want to give it a second try and like unclick the microphone, the line should go away, and you, maybe it'll work later. I don't know. Well, we'll keep an eye on the chat box.
I'm anticipating that we're going to have 4 because it's a big multiple.
And then another fun conversation would be, suppose you changed it to 12 teeth, excuse me, to 14 teeth.
Interesting.
Would you then, because we don't necessarily need to do a complete rotation, correct, or do we?
Well, I'm not sure. Oh, interesting one. They haven't met up yet.
All right, so I think we're on slide 14.
Perfect.
And I think the question is how many I initially thought how many rotations the small one would make to make a complete small circle, but I think after I clicked on the picture, I'm sorry, the link, the generation is like the circle on the white circle on the gear. When would they meet?
Hello, Renisha. How are you? Hello, Renisha. How are you? Hi there and welcome.
Hi, I'm sorry. I was having some.
No worries at all. I want to make sure you have everything so you can participate. I am putting a link in the chat box, and that will give you the link to the presentation. And what I'll do is I'll put you in a breakout room in just a moment. You'll be in group 4. And what you're going to be doing is exploring this gear activity. So once you click that link, if you come on down to slide 18, I'm going to introduce you with your breakout room.
Okay.
I think so.
Hi there, Group 4. I want to introduce you to Renisha. Just came in now and has the link to the slides. And what you're doing is you're just kind of exploring these gears. And we're on slide 18 with your group. So welcome.
Thank you.
Hi, Renisha. I'm glad you made it.
We always use multiple 4.
Of this as the relationship of the blank times as much as.
Oh, this is, I should, okay.
We're
My
going down a
numbers,
rabbit hole.
Yeah. Do we want to move on to slide 13?
Yeah.
This is a rabbit hole we don't need to go down.
this would keep me busy for a long time.
So we can even, so we don't need to go down that rabbit hole. I'd even just take off the, but if it was 14.
So if we changed it, so it took 2 rotations to get from 4 to 8. Are we all on the same one? We're in the main room, so which one are we working on?
I'm on slide
Slide
13 right
13.
now.
Okay. So
Gears. Okay.
so if I have 4 and 6,
To me, that would be 1.5 rotations
yeah.
with the thought of the as much as.
Yeah, I guess
Because
I'm
it's not going to be
confused.
as large as 2 because I don't have as many teeth to go past and as many gears to go past. Am I thinking this wrong?
It's funny that it's asking us the large gear rotations. I thought it would ask us the small gear
Small
rotation.
gear. Yeah.
Oh,
That's
so
the
you're,
answer here.
good point. So is it 2/3? Good point.
If I
Good
raise my
reading.
hand, can she see that? I'm just wondering if that's correct. If she can somehow see that. Well,
4.
let's continue going off of her model.
And did you see she's now added also to use?
Hi there, group. I noticed somebody had raised their hand. Happy to answer any questions, unless you were just kind of playing around with the tech.
No, I was going to ask a question, Teresa. So for when we look at slide 13, we're looking at our table, and then I see the small gear and the large gear, and then for large gear rotations it says 2. But does that mean, I thought that would say small gear rotations, because the small gear will rotate twice when the large gear rotates once.
Oh my gosh, it is.
Okay.
Yeah. Oh man. I'm going to go and edit that real quick on everyone. See if anyone else, I don't think anyone else is there yet. So thank you so much for that.
Should the title be different, Teresa, or should the number be different?
Well, since in our earlier one we looked at the big gear, I usually try and keep at least something constant in this. But in all honesty, you all are totally welcome to, tackle this problem any way you want. Because what we're looking at is the conceptual understanding of how do we make less broken teeth and pitted gears.
Mm-hmm.
So did we enter the one tree or did you change that?
I just went down all of them and changed them.
Okay. Maybe we'll add, what if we add another one so that we understand how long they
Yeah, that's what I was doing. So when okay.
So when the large gear rotates once, the small gear will rotate twice.
Right.
Oh, look at you guys. So now you have 2 lists happening. I wonder what relationships we'll see there.
Or you can then argue that the large gear rotates ahead.
My computer sounded like it went dead.
Oh no, you're fine. We're still here. No
So
worries.
for this table on slide 17, it's talking about, large gear rotation would be 2, right?
Yes, because that's what we determined. Like for every one rotation of this, like it would take 2 small rotations to line up with the larger one. And then 8 and 12 would be...
So group, be very specific about what you mean by large gear rotations. You might even choose to rename the title of that column because are we talking about the number of times the large wheel rotates till it meets up? Or are we talking about the number of times the small one rotates before it meets up with the large? So think about your definition and make sure everyone in your group is clear.
I see what.
Question in number 2 doesn't ask how many times the small gear goes, it's how many times.
Right.
And I don't know how to say it. To the factor.
Hi group, look at you all making another column in this group. In this table, what a great way of visualizing what those gears are doing.
I have to count both of them.
Oh,
All right, so
okay. 21.
so how do you change the gears on the small one? Can you?
On the small one,
Because I see the tables got small and large, 4 to 8, 4 to 6. Let me see. Maybe not. Oh, that's really large.
2 to 1. Okay.
Okay. So 15 is our group. Okay, it says group 2. That's us, right?
Yeah, 15, 16, and 17.
Okay, makes sense.
And I'm now seeing a connection to the hot dogs problem.
A lot of times it's not. It's like a warm-up problem just to think about math.
Right, but I'm seeing okay. Conceptually, if the gears in the large, if the teeth on the large gear, the 8 teeth, were the number of buns, and the teeth on the small gear were the number of hot dogs, then I could buy 1 bag of buns and have it match the number of hot dogs.
2 bags.
Well, yeah, it would, right. I could buy 2 bags of hot dogs and 1 bag of buns, and I'd have a match. I think there's a similar mathematical idea here.
Sarah, it's really interesting that you see that connection because it's weird conceptually in our mind to twist around gears versus thinking about set notation and grouping, which is hot dogs and buns. If it helps you to describe your thinking, the slide above the table has several virtual manipulatives that you might look at in terms of linear models on the hundreds chart or fractional models about this like meetup point. And if you do choose to do that, make sure you put a screenshot on your group slide.
Okay. And I'm imagining a number line now.
How many? The number line tune is really awesome.
Because if the large gear makes a complete rotation at 6, the small gear is going to be 1 1/2 of the way around.
So I think there you can look at it 2 different ways. I think it could either be looking at what happens to the small gear or the large gear. That's why we have like the 2 different. Yeah, it depends on how you look at it.
Right. So if this small gear were 8, it would take 3 rows rotations on the small and 2 on the large. 3 times 8 is 24, 2 times 12 is 24.
Mm-hmm.
So the outside columns multiply, the inside columns multiply, you should have the same answer. So small times small gear rotations equals large times large gear rotations.
Whoa, Anne, can you state that again?
Sure. So we have a table that has 4 columns. The outside columns must, the product of the outside columns must equal the product of the inside columns.
I see that so clearly in the visual. The words you said with the visual there really helps me to make that connection.
So I'm thinking we could just complete this because we just need to figure out 16 times what is the same as 6 times what. So 16x equals 6x. So 2 would be 32, 16 times 3, 48 times 8 is 48, so it's going to be a 3 and an 8. Yeah.
All right, so I dropped in listening to like kind of trying to match what you're saying. Like I dropped in, I'm trying to use the hundreds chart. I dropped in like a colored hundreds chart with arrows to kind of show that. And now I'm going to try to capture that thinking in for some of the other rows in the table.
Do we need to complete more rows? Is that?
Yeah, we can definitely. Yeah, sure.
All right.
I have this one that shows the
4 and
4
6.
and 6. Yeah.
Oh, I love that picture. That's a perfect. So, see if this works. If the small is 10 and the large is 50, then small gear would go 5 times and the large gear would go 1. And
I think it's starting to make sense now. I'm like processing.
7, 6, 2. Oh, wait.
No, it would be 6 and 7, right? Because you want it to be 42 or no?
Well, I was going to do where it was a 0.5, so 84. So let me think about that for a minute. Hold on. If this were 42, this would be a half rotation. This would be 7. Let's do, I can't have the large gear. Yeah, it's small, and this would be 6. Does that work?
Yep.
So the small gear is 7, the large gear is 42. The small gear has to go 6 times, and the large gear would go a half. No, that's not. This is 84. Now it's right. So the small gear is 7 and the large gear is 84. The small gear, that's silly. If we're trying to get it to 1, then this would be 42.
As we're doing this, I'm thinking about the juice recipe from the 6th grade math framework, or the California math framework. And the juice recipe was something along the line of for every 5 cups of grape juice, I need a recipe calls for 5 cups of grape juice for every 2 cups of peach juice. So I'm taking those numbers and thinking about
If you're watching this video after the fact, I did want to mention a couple things. I have given my participants a notice of 1 minute left directly on the slide. That was just copying and pasting, and I find that that's a really useful tool. You probably saw earlier I was kind of clicking around to model what it's like to have this like surprise, this show me of going through the different representations. I simply copy and pasted the stuff that I wanted to talk about on slides 25, 26, and 27, but they're still working on even more representations on their slides. And even though I was putting it together, I was still listening in on what they're saying. And there were a couple of people that I want to bring up in the talk, and that's Sarah, who compared this to the hot dog and buns problem, and Anne, who started to talk about the relationship between the small and the large gear. So you'll see those come up in the math talk as well. I'm going to pull everyone back now. Hello, everyone. Welcome back. We are all back together in the main room. I hope you had fun with this real STEM problem. My husband is a mechanical engineer, and believe it or not, we talk gears often. It's some of the stuff that he does, but also that is just mathematically and engineeringly very interesting. And so this is a real situation, and this is how people consider making certain gears. And if you come on down to slide 25, I've selected and sequenced a couple problems to go over in a whole group. And I'd love to start off with the orange model on slide 25. We'll just refer it as the orange model. If this was yours, could you tell us, what does this represent?
Hi, Teresa. That was our group. We were thinking about the relationship between the small gear and the large gear. So I was trying to show the small gear had 4 teeth, the large one had 8, and how many times it would take the small one to rotate before it met up with the large one.
Lovely. It almost looks like you peeled the gears apart and made this linear model. It's very easy to understand for me. Thank you, group. And how about this yellow model? I know that it has changed a little bit since when you first put this in, but how could fractions help us to understand this problem? And let's see, that looked like it came out of group 2. If there's anyone from group 2 who knows the way fractions can support us in understanding this problem, I'd love to hear.
Sorry, I think you were referring to the fraction bars?
Yes, indeed. Oh, I'm not sharing my screen. Let me do that too.
Oh, thank you. Yeah, I was just thinking about how the small gear, if the small gear was an eighth of the size of the large gear, then we can see there's 1/8 and 1/4. So there would be one group, or sorry, 2/8 and 1/4. Alternatively, there would be 3/12 in 1/4. So I thought the fraction bars would show that clearly.
Neat. All right, let's see if we can make some connections. If you see a connection between the orange model and the yellow model, go ahead and raise your hand. I'm going to wait till I have about half hands up before I call on anyone. If you see a connection between the orange model and the yellow model, and the raise hand button in this program is right next to your microphone. All right, let's hear from Dan. What connection do you see between the orange and the yellow model?
Yeah, in both cases, you're moving by steps. In the orange model, you're moving by essentially a unit. And in the other one, you're moving kind of an explicit measurements, if that makes sense.
It does.
Like, yeah.
I can see the units. I can see the measurements. Wonderful. Thank you for sharing. Sarah, go ahead. Tell us what you noticed.
Well, I'm noticing that if I'm trying to figure out the relationships in the fractions between the denominators, and sort of the denominators and the number of, I guess, like units of one it takes to match a unit of another amount. So I'm noticing that there are 2/8 are equal to 1/4. But if I look at the model above, it takes 2 groups of 4, or 2 times that the gear that had 4 teeth have to go around to match up with the gear that had 8 teeth. So in some ways, the denominators of the fractions the fractions have the opposite relationship as the whole numbers.
Ooh, that is cool. The opposite of the whole numbers. Anne, I can tell by your chat message that you connect with this. So Anne, if you would like, go ahead and fill in the green section for the 8 and the 12. If you see that connection, feel free to edit that table. And as Anne does that, let's take a peek at the red representation. And if that was you, would you turn on your mic and just tell us, what do you have here? And do you see connections to any of the others?
So that was me. And so what I was doing there was I was trying to show the top. It's another representation of that very first number line representation. You have the top, but at this time I'm using a double number line to try to show how if one gear had 4 teeth, sort of each hop is a rotation, and the 6 is another gear with 6 teeth, and then you could see where the arrows are supposed to show, like at the points at which the white dots on the 2 gears line up.
Oh, okay. And if you would raise your hand, if you see a connection between this red one and this row, I'd love to hear someone else kind of rephrase how this red one matches up with this row and gives us the green answers there. Oh, there we go. My microphone was off. Bloopers included. Thank you for that explanation. If you see a connection between the red model and the row that it is pointing to, would you go ahead and raise your hand? I'd love to hear your thinking on why this red representation matches up with that row. Jennifer, let's hear from you.
Yay! Okay, so I did something kind of similar, but when I was looking at that, I noticed that you've got there it is. You've got the 4 on the top, 6 on the bottom, which then simplified for every 3 4s there were 2 6s. And so for me, when I was looking at it, and it took me the entire time, but that's kind of how I saw it for the simplified form. So you've got it in fourths, the fourths there, but that was my connection with it, because I used the the fraction tiles is what I used.
So
and I did the same.
Jennifer, where do we see this, the 2 and the 3 on this model again? You said it, but I already forgot it. Could you restate that?
Okay, so let me see. So here, do I have an arrow? So I'm looking at the 2. I'm going to do this instead. I'm looking at how many there are here. So there were 2 6s. So that's where my brain went when I was looking at it. So there's 2 6s there. And then there were the 4 3s, or 3 4s right here is what I saw.
Awesome. All right. So we have 2 hops of 6 that equal 3 hops of 4. And I'm just going to put little screenshots right in there so you can see the 2, you can see the 3, and so on. Awesome. We are now ready to unpack this at another level. So why on earth are we doing this? Let's check out slide 26. This group was able to develop 2 gears, a gear size of 4 and a gear size of 14, and they got all the way up to 7 rotations. More rotations are good. That means we're not going to get warps, lost teeth, and pitted. I'm curious for you all, and just go ahead and grab a colored text box there. What generalizations can you make about maximizing rotations? And I'm going to use some nonverbal cues here just to give you a heads up that I plan on calling on you to unpack it a little bit more for us. So if you find a bright green outline around yours, that is just a heads up that I'm going to ask you to tell us a little more. And I'd love to start out with, ooh, and someone's even changing their mind on one of these. The tan colored one, where you talk about few common factors, what does that mean?
So what I was thinking was that like 4 and 8, 4 is a factor of 8, so they meet up a lot. With 8 and 12, they both have the factors of 2 and 4. But 4 and 14, they both have the factor of 2, but 14 has a factor of 7, which 4 does not have. And so I think that's why they don't meet up very often.
Ooh. So if we factor, we can find out, like we can almost continue that table. How about the green one up at the top? What does relatively prime mean in this situation?
Relatively prime connects with what she was just talking about not having factors in common.
Neat. And in the blue box all the way at the bottom, this one says maximize by using primes. Tell us more, unpack that for us.
Teresa, this is Lisa, and I remember years ago when we would teach simplifying fractions by using prime factorization, and we would divide out the common primes, and we were left with a simplified ratio or a simplified fraction. So I think you can use any two prime numbers, and the larger the primes you use, the greater rotations it's going to take before they actually meet up.
So that's interesting. So it's not just the largest numbers, but you're saying it's the largest primes. I'm going to put some numbers in here. And what I'd love is for you all to see if you can figure out the number of rotations for these. So let's do 16 and 18. And another one, so this time I'm going to use prime numbers that are also very large. I'm going to use 13 and 17. And if you all feel like you've got the hang of this table, this idea here, I'm going to have you all be the authors of the large gear rotation, small gears rotation. And tell us about your thinking about using 7 and 13. And I'm going to put that in here also so that people can figure that one out.
Okay. Do you want me to tell you now?
Yeah, go for it.
Okay. So I was thinking that if the small gear had 7 teeth and the large gear had 13 teeth, every time the large gear rotated once, the small gear would have rotated 91 times.
Wow.
That right? That is not right. Never
Keep
mind.
going with it. You've got a row at the bottom. What you're thinking is related.
Never mind.
What you're thinking is definitely related. So keep on thinking. Don't give up. Give that productive struggle a chance.
You got it.
All right. So down below that we noticed that just because you have big numbers doesn't mean that's an optimal gear size, because they're going to meet more often with a 16 and an 18 than they will with a 13 and a 17. And just for fun, I like to kind of think about exit tickets and where I'd go next. On slide 27, I think they do a good job summarizing because they have used primes. Their small gear is 11. I'll put it at the bottom. Small equals 11. Large equals 13. And what I'd love for everyone to do in the chat box is just summarize real quick. What does their hundredths chart tell us? Put your thinking in the chat, but don't hit enter yet. We'll all hit enter in 1 minute and then we'll finish up. What does their hundredths chart tell us? And no worries, we had a little mistake on here. If you recently hit the delete button, just hit Control Z and it'll come right back. And if not, I'll put a new one back in. Oh, you're doing it. Yay, good job, whoever that was. It is back on slide 26. All right, go ahead and hit enter if you have generalizations about that hundredths chart.
Are the gear sizes 7 and 11 for this 100 chart?
11 and 13.
Okay. That.
Oh, I see. Yeah, this 100 chart doesn't, I'm sorry, it doesn't go with the gears. It goes with a different set of gears. It goes with 7 and 11. And Anne, this goes exactly with what you were thinking before. If we multiply these, it is a generalization that we can make about gears. Gail, I do bring this problem up because I've been doing some gardening and I ran into a lot of cicadas. This is the exact reason why cicadas also come up on prime years. It's because they don't want to mix broods. They want to just be in their brood. And so if they come up in prime years, they're least likely to meet up at the same time. So this problem's practical for cicadas and gears. And folks, that's the end of our hour. It is already past, but I will stay on for anyone who wants to chat about mathy stuff, chat more about this problem, or some of the technological pieces. It's been a pleasure and happy MATHurdays. And again, if you'd like to stay on, happy to answer any questions. Sure thing. Glad you were able to join us. Laura, if you wouldn't mind helping me out with a little project, you know that I like my stickers when it comes to the problem-solving oath. Would you be able to proofread that other one and kind of check for spelling and, you know, grammar and that kind of stuff? And if it looks good, I want to get those in stickers too.
Sure. Do you mean the oath in Spanish?
Yeah. Mm-hmm.
Yeah, I mean, it looks fine. I'll take another look at it, but like when I read it, there weren't any mistakes that I saw.
Awesome. Yeah, I'm really intrigued with this idea of what it would look in other languages and just kind of getting this style of thinking out. But I am only fluent in one language, so I have a lot to learn and always leaning on other people that can support me in this.
Well, I used to teach Spanish immersion in Fairfax County here in Virginia, where we teach math in another language. I'll reach out to some of the other immersion teachers. We have Chinese, Japanese, German, French.
Oh my
I also teach French, but we'll check I'll reach out and see if any of them would like to translate because they teach math in those languages.
Yes, and even if it's just, you know, translating it in regular font, I'm happy to put it in fancy fonts and stuff like that. But I just think that might be a great way to bring it out. So you speak fluent Spanish and French. What other tricks do you have up your sleeve?
Just those. That's
so
not
cool.
really a trick. That's not really a trick, but yes, just those.
Awesome.
I'll reach out and see what I can do.
Thank you. Raha, I'm so glad you say your brain hurts. Hopefully it's enough that you can stay in the productive struggle zone. But it made my brain hurt thinking of this problem and putting it together because I kept mixing up the small gear and the large gear. And it wasn't until I, really looked at a table that it clicked for me. And it's something that I still think about regularly. Dan, I noticed your hand's up. If you have a question, feel free to ask it. All right, folks, see you next week. Thanks for coming.